Why do you start with a point first? So you don't plug it in the wrong thing, and it's already ready to go. You can just plug, and how do you solve for the point? What do you do to solve for a point? Plug in an x value into what? Into the equation. And what does that give you when you plug an x value into an equation? You get a y value. Sure. When you have an x and a y value, you have a point on the graph. That point on the graph is also going to be a point on the what? On the tangent line. That's why it's so convenient. A point on that graph is the point on the tangent line. So you plug in the x value into the original equation to get the y value, or the point that is on the graph and the tangent. So we have our point. What's the other thing you need in order to graph a tangent line? A slope. How do you solve for a slope? You find the derivative. You calculate the derivative of the original function, and then what do? Is that your slope? What do you have to do then with the derivative function? Plug in the x value. Plug in the x value into the derivative function, and you get a value. What is that value?
Slope.
Of the what?
Tangent.
Nice. Now that you have a point and a slope, what do?
Point slope.
You plug both of those values into the point slope form in order to get the equation of the tangent line. Does that make sense, you guys? Yes? Okay. Again, kind of a big part. That is a question that will be asked. Equation of the tangent line. What's the only difference for normal line then? How do you solve for the point on the normal line? It's the opposite reciprocal point. No. I didn't ask you anything about the slope yet. What about the point? How do I figure out the point on the normal line? It is the same point. You already solved for it. It's the same point as the tangent line. You have a curve, a nice pretty curve. You plug in some x value, and you get a point. Off of that point, you take the derivative, and you get the slope of this curve at that point. With a point and a slope, you can write an equation of a tangent line. The normal line is perpendicular to that. So you already have the point, you just need the slope. If you have the slope of the tangent line, you can take the opposite reciprocal of that value to find the slope of the normal line. Does that make sense? That's what you're going to be doing, whether it's sine, cosines, product rule, whatever it is. It's the same idea. Okay? And in this number 19, we needed tangent and normal line. Here's the tangent line. Can you guys see that? Or do you want me to turn the lights off? I'm going to turn them off. And look at this. If you go to point slope off of this, you would get y minus 1 equals negative 1 times x minus pi over 4. And then if you wanted to graph it, you see it, David? You can just like add the 1 to both sides then. Now it's in y equals 4 if you wanted to graph it or something. You know what I'm saying? Does that make sense? Okay? And then here's the normal line. The only difference is you take the opposite reciprocal of 1. That's the only difference between those two things. If you do the y equals mx plus b, that b is going to change. Does that make sense? It's a completely different b, so you'd have to solve for something else. But you have the point that you want, you have your slope, so you're all ready to rock and roll. So you take the opposite reciprocal of that slope and you're good. Okay? For 22, here's 22. A is negative 4. There's your point right there. There's your point in 22. 3 pi over 4, comma 2. That's the coordinates for Q. Now I'm going to talk briefly about 23. What's the original equation for 23?
S equals 2 minus 2 sine t.
Graph it. Everyone take a look at S equals 2 minus 2 sine x. Or T, is it T?
Yeah,
Sonia?
T.
Okay. And S. What is this? position 4. Yeah, position at any given time. Position over time, I'm thinking derivative or something. Okay, so let's take a look at the graph. Does everyone have their calc ready to go? 2 minus 2 sine t. Make sure you're in the right mode. I'm going to do a zoom trig. Okay. So here's my position equation. What is my position? Where am I at time 0? How did you figure that out so mathematically quickly? What did you do? How did you figure that out? Why are we whispering it? You know I can't.
Looked at the table.
Sure, you just look at the table, you look at 0, 2, you can see it looks like it crosses. Off the equation, what is sine of 0? What is the y length of this reference triangle?
0.
That y length is 0. You should be able to do this question with or without a calculator. Okay? Again, if you need practice on it, let's do this. The y length of the reference triangle is 0, so sine of 0 is 0, leaving this as 2. Here I am. I'm standing at 2. You see me? Do you see me right here? Do you guys? Here I am. Where do I go? As time moves on, where do I go? Do I go right or left? What number do I go towards?
0.
At time pi, time pi over 2, that's counting by pi over 2 pi, 3 pi over 2, 2 pi. At time pi over 2, where am I?
0.
I'm at 0, so I just moved which direction? I've just moved left. I've gotten less y value, I got less position. I've just moved left. And then what happens? I turn around. And I go where? So what number? Well, I go to 2, and then what happens? I keep on going to what?
4.
Here I am. What time am I at 4? If those are counting by pi over 2s, that's 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2. So here I am at 3 pi over 2. Now this thing continues on. I can't see it in this picture, but where do I go then? Back to 0. Here I go. Then where do I go? I turn around and go where? Here I go. That's what's... I don't understand. That's what's happening here. I start at 2. That's what this graph is showing. I start at 2. I go left to 0. And then I go 4, 0, 4, 0. And that's all I do forever. Okay? Take a look at the velocity graph. The derivative of this is going to be what?